Hi, thanks for having me, and thanks everybody for being here. So I'm going to present on behalf of our team about life cycle analysis. My team includes Matt Kingston, Cev Jennings, and Nath and Mohammed Gamal Al-Din. And what we're presenting on this life cycle analysis is what we're trying to do within the land and water reclamation theme. So this theme has a number of excellent scientists and engineers who are working on various novel materials to try to solve a particular problem, which in this case is what to do and how to clean up oil sands process water. So in this water, there's pollutants, some organic compounds like methylic acids, as well as inorganic compounds like heavy metals that need to be removed before that water can be returned to the ecosystem. And so the purpose of our project is to analyze and compare these different materials so we can get a sense of what would be the best one to use. But before I tell you about my project, I'm actually going to get you to do something for me. I'm hoping that Valerie can put this, this poll up. And based on the information on the slide, what material do you think would be better for cleaning up oil sands process water? Is it biochar or chicken feathers?
We are tied 50-50 right now. It is bouncing back and forth. 43% biochar, 57% chicken feathers. We'll give it another like 10 seconds if you haven't voted yet.
Yeah, maybe we should. Let's close it for now, just so I don't run out of time at the end.
All right.
Can you show the results? So it's about 50-50, which I'm not very surprised by. So what we're trying to do is answer the question that I've just asked you. Which of these might be better for dealing with oil sands process water? And to do that, our method is life cycle analysis. So you can see here there's a boundary which represents the edges of what is included in a life cycle analysis. And you can see in this conceptual model all of the different steps that could be included. So you start with the farm, it's transported into the lab, which is that dark dotted box. And then there's various steps that happen in the lab before it's transported out of the lab into the wetland. And then ultimately we hope to understand and analyze the movement of that material into the wetland and then eventually out of the wetland and into disposal, or if it's possible to recycle that material back into the lab. So this is the conceptual model, but life cycle analysis itself is actually quite complicated with a number of steps. So here's one map that shows many of the steps that's included in actual life cycle analysis. You can see there's the farm here, as well as steps 2 to 5, which happen in the lab. In these steps, it's transported, it's heated, it's dried, it's characterized and packaged, and then eventually moved out to the wetland and then disposed or recycled. And in this map, what's important to see is that there's, for each of these tiny steps, which are within these broader phases or larger steps, you have inputs into that process. So these would be things like electricity, and then you have outputs, which would be things like like heat, for example, from heating the material itself. So that waste heat that would come out of it. And the point of adding all of these up and looking at this whole process is that we are able to then understand the full impacts and full inputs and outputs of the whole process of creating a material. So here, like I mentioned, there are 7 steps for the biochar, but for the chicken feathers technology, we have even more steps, including, for example, in this one, steps 4A and 4B are 2 different possible processing techniques, which have different input and output characteristics or materials that will be used and then come out of it. So what I really want you to understand here is that these processes are really complicated. And so what this method allows us to do is take into account all of these inputs and outputs of this very large and complicated process so that we can compare the overall effects of creating and manufacturing these technologies. So how we do that is this is called OpenLCA. analysis software. And you can see here we have lots of inputs like the actual chicken feathers themselves, tap water, for example, and then you have the outputs, which include the chicken feathers, or for some of the other steps you would have, like I mentioned before, heat or carbon emissions. We're hoping to move forward and get some more detailed information from mesocosm trials that might be happening very soon. So we can get more detailed information to put into that open LCA analysis. And ultimately, our goal here is to answer this question that we asked you: what material is going to be better for cleaning up oil sands process water? And to do that, if we understand the whole material process, hopefully we'll be in a good position to answer that question. So thanks so much. And I'll just leave you with final words from Matt Kingston, our tech guru.
Hi everyone, I'm Matt Kingston. Sorry I couldn't be there today. I'm working in the storeroom. I look forward to working with you in person though. Thanks.
And if you have any questions, please feel free to contact us. Thank you so much.